Okay, so here's a continuation of solving rational equations. So the examples we looked at so far, all our denominators were known values, and so we uh, we didn't have too many issues with that. As we move forward, we're going to make it a little bit more complicated. It won't be too bad, but what we're going to do is now our denominator will have some variables, some unknowns, and so you have to keep those restricted values in mind. So that's the first thing you want to do is just go ahead and list values that x definitely cannot be. And for this first example, x could definitely not be 0, because if I let x equal 0, I'd end up getting undefined on both sides, because 4 divided by 0 or 5 divided by 2 times 0 would cause an undefined expression on both sides, and that'd be a problem. So now that that's out of the way, just keep that in mind in case that comes up as your answer. We have to actually exclude it, okay? So next step is LCD. So the LCDs are going to be a little bit more complicated now just because they're going to have a variable involved. But as I look at all of them, let's see, it's just going to be a 2x, okay? So look at the numbers first. So 1, 2, 1, and then look at the variables. Take the one with the highest power, which is just x. So what we're going to do now is we're going to multiply both sides by 2x. Basically, all the numerators are going to get multiplied by 2x. And if you want to multiply, you can. As they get more complicated, and as I did in the previous video, I kept them separate. I didn't actually multiply the 2x and the 4 together yet. And I'm just going to continue with that pattern to kind of get that habit in place. Because it will, as we move on from here, some of them will get a little bit more complicated, and it's makes life a little bit easier if I actually wait. Now on this one, 3 times 2x, I'll go ahead and multiply that because that's not going to make a difference. So that'll be 6x over 1. If you want to wait, that's fine. But that one doesn't really make a difference because nothing's going to cancel out here. Okay, on the first part, the x's will cancel out, so I'm left with 2 times 4, which is 8 equals. And then here, the 2x's completely cancel each other out, and I'm just going to be left with a 5. And then I have plus 6x. All right, so then from here, fairly simple to solve this, so we'll subtract by 5 to get started. So let's see, that'll give us 3 equals 6x. And then we'll divide both sides by 6, and we're going to be left with 6 equals, and then when I simplify that, that will become 1 half. 1 half. All right. Okay, on 35, it's actually going to be quite similar to what we just saw on this previous one. We just have a little bit more going on. Once again, the restricted value is just going to be 0, because if you plug in 0, you'd have some issues with dividing by 0. So when I find the LCD, let's focus just on the numbers for a minute. So let's see, 3, 4, 6, and then 3 again. So I'm looking for a number that all those numbers would divide into evenly. And so start with the biggest number. Let's see, 6. Let's see, 3 goes into 6, but 4 doesn't. So double 6, go to 12. Let's see, 12. Let's see, 3 would divide into 12, and so would 4. So my LCD is going to be 12, and then I also have to include any variables that show up. And so it's going to be 12x. And so that's what I am going to multiply both sides by. I'm going to multiply both sides by 12x, basically, just the numerators. And once again, if you want to multiply them, you can, but I'm going to keep it separate. So let's see what I have here. 12x times 2 over 3x plus, well, 12x times 1. I'll just go ahead and multiply that. 12x over 4. And then equals, let's see, 11 times 12x all over 6x. And then minus 1 times the 12x. So I'll just put 12x and then over 3. And then I should be able to, all these fractions are going to reduce and they should no longer be a fraction. So let's see. The 12 and the 3 would reduce down to a 4 and that to a 1, right? And then the x's, you can just cross those out. Those cancel out. So I'm left with 4 times 2 on top, and I just have a 1 on bottom. So 4 times 2 is 8. And then plus, let's see, the 4 cancels with the 12 down to a 3. So that will become 3x, and then equals, And then right here, let's see, the x's cancel out. Then the 6 and the 12. So the 12 reduces to a 2. 2 times 11 is 22. And then the 3 and the 12 will reduce down to a 4, and then the x is still going to be there, so that will be a 4x, so minus 4x. All right, so now this should look like a problem we've done previously. It's just, linear equation, so we'll solve this. So let's see, I'm going to start by adding 4x to both sides. And you might want to do this differently. That's fine. This is the way I'm going to do it. 8 plus 7x equals 22. Then I'm going to go ahead and subtract 8 from both sides. And I'm left with 7x equals 14. Then we'll divide by 2, divide by 7. I'm getting ahead of myself. My answer is 2. So x equals 2. And then just for good measure, I look back, that's not my excluded value. No, it's not. So I know that that answer is good. 2 is my answer. So once again, just make sure we're understanding this. If I were to plug 2 everywhere I see x up here, if I were to plug 2 in for here and here, the two sides would be the equivalent. Okay, and if you look at the question originally, that almost seems like an impossible question, right? That seems pretty challenging. But once we get rid of the fractions, it makes life a lot easier. And so our answer is 2. If you plug in a 2 here and here and simplify both sides, they will be the exact same on both sides. All right. All right, looking at this one here, let me give myself a little bit more space to start. Okay, so once again, my restricted value is going to be that x cannot equal 0, because divide by 0, that'd be a problem. LCD is pretty basic on this one. The LCD is just going to be a 2x. So that's what we'll do. We'll multiply everything here by 2x. So once again, so this gets multiplied to both of those right there. Now I'm going to leave the 2x on the outside of x minus 2. Oops. A little messy there. And then all divided by 2x. And then plus, I'm just multiplying it by 1, so that's fine, 2x, and you can keep it over 1 if you want. And then on the other side, let's see, I'm going to have 2x times x plus 1 divided by x. So now we simplify all these. So on the first one, the 2x's cancel out. Actually, that works out pretty nice. So that just leaves you with x minus 2. Then here I just will have 2x because over 1. And then here we'll go ahead and cancel out the x's. And that will leave me with 2 times x plus 1. If you wanted to distribute, you could. I'm going to do it now. While I'm doing that, I'm going to clean up the left side. So the left side, I can combine those x's. And so that will give me 3x, and then I have minus 2 equals, and we'll go ahead and distribute, and that will give me 2x plus 2. And then, let's see, I'm going to subtract 2x from both sides. And that will give me x minus 2 equals 2. Then I'll add 2 to both sides. And so we get x equals 4. And that's not my restricted value, so it is a good answer. Once again, if I plug that in everywhere I see x, it makes the two sides the same. I think, I don't know. I think that's pretty cool. All right, let's see. I think I have, okay, I do have 2 more slides. Okay, so now our denominators are going to get even a little bit more interesting. We've seen stuff like this on some of our other fraction sections, okay? Now this time, my restricted value is going to be a little different. X cannot equal positive 1 in this case. So it's been 0 so far, but now it's going to be a 1, because if you plug that in, it will cause you to divide by 0. Now, my LCD in this case is that factor, x minus 1, okay? And so I have to multiply all these numerators by that, and that's what we'll do here. So x minus 1, x minus 1. And so it has to get multiplied to both of these on the left side. So let's see, I'm going to end up with an x minus 1 over an x minus 1. That's interesting. And then let's see, plus 5 times x minus 1 all over 1. And then equals 11 times x minus 1 over x minus 1. This looks like everything's going to cancel out pretty nicely here. And so this problem actually shouldn't give us much trouble. So right here, just be careful. Yes, they cancel out, but what it really happens is they reduce down to ones. So that actually turns into a 1. And then I'm left with plus 5 times x minus 1, which you could distribute if you want to now, but I'll wait. Then these cancel out to ones, and I'm left with an 11 right there. So now what I'm going to do, now I'll go ahead and distribute my 5, and I'm going to move up here where I've got more space. So I'm going to have 1 plus 5x minus 5 equals 11. And then from here, I just need to solve this. So let's see, 1, take away 5. That would give me 5x minus 4 whenever I combine those constants. And then now we'll go ahead and add 4 to both sides. So we got 5x equals 15. Then we'll divide by 5 on both sides. And we get x equals 3. And that's not my restricted value. So that is a good answer right there. Okay, so our next one looks pretty identical to the one we just did. It should be pretty similar process. So let's move on down. Okay, so always put this in parentheses. Okay, that's your factors in your denominator spot. Put an understood 1 there. This time my restricted value is that x cannot equal -1 this time. Okay, just a little note in case that comes up as my answer, then we'll have to discard it. So my LCD on this one is going to be x plus 1. And actually, I guess I should move that over so I have room right there. So x cannot equal -1. Okay, that would be better. All right, so now I'm going to multiply both sides by x plus 1. All right, and then on the right side, I got to make sure I distribute it to both parts. So let's see, I'm going to have an 8x times an x plus 1 all over x plus 1 equals 4 times x plus 1 all over 1 minus 8 times x plus 1 all over x plus 1. All right, so now we'll start, canceling out common factors here. So this just reduces down to an 8x. And then here, if I want to, I can go ahead and distribute now. I'll go ahead and do that. So let's see, 4x plus 4. And then the x plus 1's cancel, and that'll leave me with a minus 8. So now I want to clean up the plus 4 and the minus 8, and I'll pull that up over here to finish. So see, the left side's 8x, the right side will be a 4x, and then that'll become a minus 4 right there. Okay, and so now we'll go ahead and subtract 4x from both sides. That cancels out. That'll leave us with 4x equals -4. Then we'll divide by 4 on both sides, and we'll get x equals -1. Uh-oh, I got a problem here. That's my restricted value. So we haven't seen a problem like this before. And what that means is actually there is not a solution to this problem. The one I came up with, if I plug it in, I get undefined, and undefined is not an answer. It's undefined, right? So in this case, we are going to have no solution. So no solution. So you'll see that option on every single problem when you're doing your homework. Most of them will have a solution, but you'll have a couple in there that are no solution. So that's what we're dealing with here. Okay. All right, so 43, pretty identical to what we've been working with. The only difference is that my factor on the first one, it is factorable, so I want to go ahead and do that. I'm going to factor out a 2. That'll leave me with x minus 1 on that first fraction. Then let's see, I'm going to have plus 1/2 equals 2 over x minus 1. All right, so once again, my restricted value, what would cause my denominator to equal 0? That would be 1. So x cannot equal 1. We'll want to keep that in mind as I work this problem. Now, as far as my LCD goes, let's just look at the numbers first. So don't look at the parentheses. We have the number 2 and 2, so that's going to be part of my LCD. Now we look at the parentheses, and they're the same, so you only have to write it once, x minus 1. That is my LCD. And the way you know it is that all the denominators, when you take them individually, they will all divide into this evenly, and that's what we're looking for. So that's what everything will get multiplied by now. And let's see, I don't have quite enough room here. All right, I cleaned that up a little bit. Oops, not quite all the way. Let's see. Just sneak that in there. Okay, so let's see. We're going to multiply by 2x minus, I'm sorry, 2 times x minus 1 on both sides. So 2 times x minus 1. And I do need to distribute, right? Right there. Okay, so let me go ahead and try to clean this up a little bit. So I like to put the numbers in front. So I'm going to have 3 times 2 times x minus 1 all over 2 times x minus 1. So that's my first one right here. You see the 3's there. Now all of a sudden, now I have the 2 and the x minus 1 with it. Then on my next one, let's see, you're multiplying by 1. So 1, you get the same thing in return. So I get a 2 times x minus 1 all over 2 equals, and then here I'm going to have a 2 times a 2 times an x minus 1 all over x minus 1. All right, so now what we'll do here, I'm going to give myself some more space. Okay, so now what we'll do is start canceling stuff out. So that goes, that goes. That'll leave me with a 3. So once you get to this point, it's pretty easy, right? Everything simplifies down pretty nicely. Here I'm left with 2 times 2, which is 4. Now let's see, 3 minus 1, that would give me a positive 2. I'm left with a 4 on the right side. Then we'll subtract by 2 on both sides, and I get x equals 2. Okay, I know I did that kind of fast, but I'm hoping once you get to this point, you know, it should be a pretty quick to the end. Okay, all the hard work is here in the beginning. My restricted value was 1, so I'm good to go. 2 should be fine. And you could always check it if you want to plug it in. I mean, the algebra is not super simple, but, you know, it could be some good practice to plug it in and see that the two sides are equivalent. All right, I got one slide to go. All right, so here we go. So once again, I can factor this a little bit here. So let's see, I've got an x plus 1, x minus 1, and then I've got x squared minus 1. So I've got the difference of 2 squares. So let me go ahead and write that here. And I think I'm going to show y'all a little faster way of doing this. I kind of showed you this on some other problems we've done. So let's see, I'm going to give myself a little extra space. So x plus 1 and minus 1 over x minus 1, and then equals 2x. And then when I factor this, it's going to be x plus 1, x minus 1. Okay, so I have 2 restricted values this time. X cannot equal negative or positive 1. Okay, because if it equals negative 1, it causes an issue with these two over here. And then if it's a positive 1, then it would affect the middle one and the one on the right. So either one of those numbers is no good if that comes up. Okay, now the LCD, we look at the factors. And so let's see, we have an x plus 1, then we have an x minus 1, and then you have a repeat. So don't worry about writing it a second time. Now just just so you know, let's say that this one was squared. Well, then you'd have to put a square with your LCD. But I don't know. I don't think we're going to run into any of those today. But it could be something you might see in another course. Okay, so now what I'm going to do, I'm going to kind of show up here where I'm going to multiply both sides by, and then I'm just going to sneak them in down below. It just saves a little bit of time and space. So I'm multiplying by the LCD on top on both sides. So basically I'm just going to insert that everywhere up here. So I'm going to have an x plus 1, x minus 1, same thing here. Okay, so basically I multiplied all my numerators by the LCD, which is x plus 1, x minus 1. Now we'll go ahead and start canceling things out. So this would cancel with this. That will leave me with 2 times x minus 1, so we'll have to distribute in a minute. Then here this would cancel with this one. That'll leave me with minus 1 times x plus 1. Need to keep that in parentheses there, okay? And then equals, both of these cancel out, and that'll just leave me with a 2x. And once again, like, the hard part should be over at this point. We should know how to solve this fairly easy. We've done quite a few of these. And this dates back to our very first unit. So we'll go ahead and distribute here and here, and I got to do the same with the minus 1. So let's see, we get a 2x minus 2 minus x minus 1 equals 2x. Then 2x minus x is x. Minus 2 minus 1, that will give us a minus 3 equals 2x. And then last but not least, we'll go ahead and subtract an x from both sides. And that would leave us with negative 3 equals x. And then my restricted values were positive and negative 1, so I'm good to go. That's a good answer right there. That's a good answer. Okay, I think I have, yep, this is our last one. It's pretty similar to the one we just did. Pretty identical. So let's see, I have x minus 4, and I have an x plus 2, and then I have a trinomial this time. That's really the only difference. And so I'm going to have to do the A&M method to go ahead and factor that in a second. And I'm going to go ahead and do this kind of like I did the last one to save myself a little time and space. So I'm going to put 1 over x minus 4 minus 5 over x plus 2, and then equals 6 over, and then I got to factor that, which it's going to factor into those two factors I already have. I mean, it's pretty much done by design for that to happen that way. So in fact, oops, x minus 4 and then x plus 2. Okay, so restricted values. X cannot be a 4, and it can't be a negative 2. Okay. And then let's see, our LCD is just going to be the factors x minus 4 and x plus 2. Okay, so x minus 4, x plus 2, and then there's a repeat of them, so I'm good to go. So then all the numerators are going to get multiplied by that. So I'm just going to show my work just so to be careful here. So multiply that here. And we'll do the same thing in those two spots. And then what I'm going to do is I'm just going to kind of sneak it in. That's why I left that room there. All right, so I snuck that all in there. And so now we'll start canceling out. Oops, got a parentheses right there. All right, so the x minus 4's cancel out. So I'm left with 1 times x plus 2. Then let's see, that cancels out. So I'm going to be left with minus 5 times x minus 4 equals, and then all the factors cancel out here. I'll be left with a 6. All right, so then let's see, all we have left here, distributing the 1 doesn't change anything. That'll just be x plus 2. And then we'll distribute the minus 5, so minus 5x plus 20 equals 6. And then we'll go ahead and clean this up. So let's see, x take away 5x. See, that'll be a negative 4x. And then a plus 2 and a plus 22, or I'm sorry, plus 20 would be a plus 22 equals 6. And then let's see, we're going to subtract 22 from both sides. Clean that up over here. So let's see, negative 4x equals, what is that, negative 16. And then we'll divide by negative 4 on both sides. So we get x equals positive 4. All right, great. All right. Oh, wait a second. Wait a second. What were my restricted values? Oh, wait. X cannot equal 4, so that's no good. That's no good. So it's going to end up being no solution. Okay. So most of the ones you work will have solutions, but you'll have maybe 2 or 3 in the homework where you're going to come up with no solution. So just be careful with that. And so, you know, this topic can go a lot further, to be honest. But this is really all we're going to need to kind of move us forward and get ready for our college algebra. But if you do go on to pre-cal, you'll hit on this stuff again, and you'll even go a little bit further. The factoring might get a little bit more interesting, or sometimes you actually get 2 answers. Sometimes you get 2 correct answers. But we kind of left this with more as an introduction, okay? So moving on from here, we're actually going to kind of change directions. From here, we're actually going to start looking at radicals. So we're going to move away from fractions, and we're going to look at radicals.